Hi, it's Rob. Welcome to the next video in the Infrastructure as Code on AWS with Terraform playlist, where we'll discuss Terraform State. As we can see in the HashiCorp documentation on Terraform State, Terraform requires a mechanism for storing the state of your managed infrastructure to map real-world resources, referred to as the current state of your infrastructure, to your configuration, referred to as the desired state, as well as to track metadata and improve performance for large infrastructures. By default, Terraform stores state in a terraform.tf state file in the current working directory of your project. The tf state file, as it's commonly referred to, is a JSON file which is created when you run a Terraform apply. Jumping into VS Code, we see I have a simple main.tf file. It has a Terraform block with a required version of Terraform, a required providers block for the AWS provider, then a provider block for the AWS provider, specifying the region of US East 1. And I have a resource block of AWS instance, which is an EC2 instance, with an AMI for an instance type of T2 micro in the US East 1 region. My IAM credentials have been configured on my local machine using AWS configure, so I'll run a Terraform init to initialize my project, and we see we now have a .terraform folder with a provider for AWS. Now I'll run a Terraform plan, and we see we have one resource to add, which is our AWS instance. However, if we look over in the Explorer pane, we see we don't yet have a terraform.tf state file. So I'll go ahead and run a Terraform apply, and now we see the creation of the terraform.tf state file. So let me go ahead and enter yes to provision the infrastructure. And with the apply complete, let's jump into the terraform.tf state file and take a look. So here we can see this is a JSON file with several properties and values. One of which properties is the resources, whose value is an array of resource objects. Here we see that this resource is a managed resource of type AWS instance. Its local name in Terraform is referenced by web server. The provider for the resource is the AWS provider, and we also see attributes for the instance. Now let's jump back into our main TF file, and we'll add a tag to our web server instance. Now I'll save the file, and go back to the terminal, and run a Terraform plan. And as expected, we see we have one resource to change. It's the AWS instance resource, and the change is to add a tag for the name of web server. Now, before we apply this, if we jump back into the terraform.tf state file, we see that our instance currently has no tags. Now I'll go ahead and apply the plan, and we'll see after the apply is complete and the one resource was changed, inside of the terraform.tf state file, our EC2 instance now has a tag with the name of web server. Looking over at the Explorer pane again, we see in addition to the terraform.tf state file, we also have a terraform.tf state.backup file. And this backup file is created after a successful apply. Now let's jump back into the main TF and modify our tag, and if we do a Terraform plan, as expected, we see we have one resource to change, and that's to change the tags for our EC2 instance from the name of web server to the name of web server 1. Now, if I delete the TF state file and run a Terraform plan, we see that we no longer have one resource to change, but we have one resource to add. And that's because without the terraform.tf_state file, Terraform can't reconcile the difference between our Terraform configuration in our main TF and the infrastructure that's been provisioned on AWS. However, if I rename the terraform.tf_state.backup file to terraform.tf_state and run the Terraform plan, now we see we have one instance to change because we have the terraform.tf_state file. Now, as mentioned, by default, the tf_state file is stored locally in your project's working directory. And this mechanism for storing the state file is called a backend. And when Terraform stores the backend on your local machine, it's referred to as a local backend. Now, using a local backend is adequate for a single developer or for testing, but not really useful for collaboration on a development team. So when it comes to supporting a collaborative environment, we use a remote backend, which allows us to save state to a remote data source such as AWS S3. This allows sharing of the state between distributed teams. It also allows for sharing of output values defined in your Terraform configurations with other Terraform configurations. And it provides better availability and security of your state file in the cloud. Now, before we look at implementing a remote backend, there's one more concept regarding state that I want to discuss, and that's state locking. State locking, which is implemented in both local and remote states, prevents parallel Terraform deployment execution by multiple developers. So the first developer to issue the Terraform apply will lock the state until the deployment completes. And if we jump into VS Code, we could take a look at that. So here in VS Code, I have a new demo2 folder, and inside I have a single main TF. I've added a Terraform block with a required version and a resource of a time sleep, which when the resource is provisioned will sleep for 3 minutes. Now, I'll go ahead and run a Terraform init. And if we look inside the .terraform folder, we'll see the Terraform time provider. Now, I've opened up 2 terminals, both in the demo2 folder. On the left, I'm going to run a Terraform apply. Now we see that the plan indicates there's one resource to add, which is our sleep timer. And we can see the timer being executed while the plan is being applied. Now, over on the right-hand side, I'll execute a Terraform plan. And here we see I have an error acquiring the state lock. Now, if we look over into the Explorer tab in VS Code, we see we have a .terraform.tf_state.lock.info file. And it's this file in our local state which locks the state from allowing a write execution by another developer. And here we're just simulating the other developer in the second terminal. Now, when the execution of the apply completes, the Terraform's tf_state lock file will be removed and the lock will be released. So I'll just pause the video until the 3 minutes is up. And after 3 minutes, the apply is complete. The one resource was added, which was our timer. And if we look back into the Explorer pane of VS Code, we see that the lock file has been deleted. So if I come back over to this other terminal and run a Terraform plan, I have no problem executing it because the state isn't locked. Now, the Terraform state lock file is a great feature indeed, but it really doesn't add much of a benefit when you're one developer using a local backend. However, when you store your state in a remote backend, that's where the lock really comes into play. So what we're going to do now is to deploy our state to a remote backend. And since we're working with the AWS provider, we'll be storing our remote state in S3. However, I want to point out that S3 in and of itself doesn't support state locking. So in order to support state locking, we also need to incorporate a DynamoDB table. So to get started, I've jumped into the Amazon S3 console, and I'll go ahead and create a bucket. And I'll give the bucket a name of ccdemotf state backend. Then I'll scroll down and create the bucket. Now I'll go into the bucket and create a folder named tf-infra and create the folder. Now, as previously mentioned, S3 doesn't support state locking on its own, so we need to create a DynamoDB table. And looking at the DynamoDB state locking documentation on the Terraform site, it indicates that the table name must have a partition key named lockID with a type of string. So let's jump into the DynamoDB console and create our table to support state locking. So I'll go ahead and create the table. I'll give it a name of Terraform State Locking and add a partition key of lockID, which is of type string, and create the table. Now with the table created and active, we could jump back into VS Code and add our remote backend. So back in VS Code, inside of the Terraform block, I'll add a new backend block for S3. I'll set the bucket property equal to the name of the bucket I created in the S3 console, and the key will be the folder I created inside of the bucket, and the object name will be terraform.tfstate. The region will be US East 1, and I'll set the DynamoDB underscore locking property equal to the name of the DynamoDB table I created. Now I'll save the file and do a Terraform init. And we see that the backend was successfully configured to use S3. Locally, we have a .terraform folder with the providers. And if we go into our S3 bucket and go into our folder, we don't yet have a tfstate file because we haven't yet done an apply. So let's jump back into the two terminals and execute a Terraform plan, which shows we'll add one resource, which is our sleep timer. Now I'll do a Terraform apply, and we see our resource is being added and our sleep timer is being executed. So in the other terminal, I'll execute a Terraform plan, and we see I get the error acquiring the state lock. Now if I go back to VS Code, we'll see that there's no terraform.tfstate.lock file here because we're using the remote backend. If we go back to the AWS console and go into the DynamoDB console and explore our table items, we see we have one entry, which is the current lock on our state. Now I'll pause the video until the timer completes. And now with the apply completed, if we go back to the DynamoDB table and view our table items, we see our one item returned is a digest of a prior lock, not a current lock. So if I go back to the terminal and run a Terraform plan now, we see that instead of getting the error on the lock, we get a message indicating that we have no changes to our plan. And if we go to the S3 bucket and refresh the folder, we see our remote terraform.tfstate file. Now, what I'd like to do is revisit the code from the last video in the playlist and implement a remote backend for that configuration. If you watched that video, you'll recall that we deployed a 3-tier infrastructure on AWS and implemented the code using Terraform modules. I won't walk through that implementation here, but feel free to pause this video and go watch the prior one in the series if you'd like to see how that code was written. So to get started, I created a new folder named 3_terraform_state. And I copied the source configuration files from the Terraform modules project into this folder. If we open up the main TF, we see in our Terraform block we have a required version and a required providers block for AWS. Then inside of the providers.tf file, we have a provider block for AWS. I set the region to US East 1, and of course, my AWS credentials have been configured using AWS configure. Going back to the Terraform block in the main TF, we see we don't have a backend block. So currently, this project is configured to use a local backend. Now, to initialize the Terraform project, I'll open up a terminal and run a Terraform init. And our project has been successfully initialized, and we see our .terraform folder with our modules and providers. Now, inside the modules folder, I'll create a new folder named TF State. And inside that folder, I'll create a new file named tfstate.tf. And this file will be used to define the S3 bucket and DynamoDB table for the remote state. And I just want to mention that I deleted the bucket and the table I had created in the last demo so I can reuse the resource names here. So in this file, I'll add a resource block for an AWS S3 bucket, and I'll set its bucket property equal to a variable which will pass in containing the bucket name. Then I'll add a resource block to add versioning to the bucket, as well as enable server-side encryption, because if you recall from the prior video in the series, the TF state file contains secrets in plain text, so encrypting the file on the back end will add a layer of protection. Then I'll add a resource block for the DynamoDB table, setting the table name property equal to a table name variable that will pass in, and making sure to set the name attribute equal to lock ID and giving it a type of string. Now I'll create a new variables.tf file and add a variable for the bucket name with a validation condition, ensuring that the bucket name conforms to S3 naming conventions, as well as add a variable for the DynamoDB table name. Now I'll save the file and jump back over into the main TF and add a module for the TF state, with the source pointing to the TF state folder in the modules folder, and then pass in variables for the bucket name and the table name, which will come from the locals.tf file. So opening the locals.tf, we'll see that I added values for the bucket name and the table name equal to the values we used in the prior demo. Now I'll go ahead and save all the files, and in a terminal, I'll run a Terraform format, then a Terraform init to install the new module. And we see the TF state module has been installed. Now I'll run a Terraform validate, which is successful, then a Terraform plan. And here we're prompted for a DB username for our RDS database module that we created in the prior video, as well as the database password. And we see the plan is to add 29 resources. Now, most of those resources will be for the infrastructure that we created in a prior video, the VPC, the database, the web server. And of course, now we have the resources for the S3 bucket and the DynamoDB table. Now, before we can go ahead and apply the plan, we need to jump into the EC2 console and create a key pair for our web servers. I'll give it a name of CCKP and create the key pair. Now I'll jump back over to VS Code. Now I'll go ahead and execute a Terraform apply to apply the plan and provision the resources. Now, this will take a while, so I'll pause the video until the provisioning is complete. And after a little over 5 minutes, our resources have been provisioned. Now, of course, most of these resources have to do with our 3-tier infrastructure, but if we jump back into the AWS console and go into the S3 buckets, we see the new bucket for our Terraform State backend. Of course, right now, there's no TF state file in here because we haven't implemented the backend, we've just created the infrastructure. And the same for the DynamoDB table. And coming back into VS Code, of course, we see our terraform.tf state and terraform.tf state backup files in our local backend. So what I'll do now inside of the Terraform block in our main TF file is add the backend block for S3. I'll set the bucket name equal to the bucket that we created when we provision the infrastructure. I'll add a key for the terraform.tf state file and specify the name of the DynamoDB table and set encryption to true. Now in the terminal, I'll run a Terraform init and answer yes to copy the existing state to the new backend. And here we see that we've successfully configured the backend to S3. And if we go back to our bucket, now we see we have a new TF infra folder and inside the terraform.tf state file. Now, what I'm going to do is I'm going to change the instance type for our EC2 web servers from a T2 micro to a T3 micro. And of course, I'll have to change the AMI ID. Now, in the terminal, I'll run a Terraform plan, and we see we have 4 resources to add and 4 to destroy, which will replace our existing 4 EC2 instances. So I'll go ahead and run a Terraform apply. And with the apply complete, if we jump back over into the AWS console and refresh our bucket objects, we see our remote terraform.tf state file has been updated. So now that we're successfully using a remote state for our infrastructure, I want to jump back into VS Code and look at some Terraform state commands that are used for reading and manipulating the Terraform state file to remove and change resource attributes. The first command is Terraform state list, which will list all the resources being tracked by the TF state. In here, we see the resource addresses for all the resources defined in our Terraform configuration. If we copy one of the addresses, we could do a Terraform state show, passing it the address, to get detailed information on that resource. Another Terraform state command we can execute is Terraform state rm, passing it the address of a Terraform resource we'd like to remove from the Terraform state file. Doing this will unmanage the resource from Terraform, but it will not remove the provision resource on AWS. So to remove our web servers, first I'll execute a Terraform state rm, passing the address of AWS instance web server 2, and web server 1, and we see that both web servers were successfully removed from the Terraform state. And if we jump over to the AWS console and refresh the bucket objects, we see our state has been updated. And if we jump over to the EC2 dashboard and click on running instances, we see that our 2 web server instances of T3 micros are still up and running. Now, the final topic related to Terraform State that I'd like to discuss is Terraform Workspaces. As we know, each Terraform configuration has an associated backend, and the data persisted in the backend belongs to a workspace. By default, the backend initially only has one workspace, which is known as the default workspace. But some backends, such as local, support multiple workspaces. And if you haven't used the Terraform Workspace command to create additional workspaces, by default, you're working in the default workspace. Jumping into VS Code for this workspaces demo, we'll see I have one main.tf file. It has a Terraform block specifying the required version and a required provider for AWS. There's a provider block for AWS and an AWS instance resource. I'll go ahead and run Terraform init to initialize the project. And then execute a Terraform workspace list. And we'll see we're in our one default workspace. Now, to create additional workspaces, we can use the Terraform workspace new command and pass it the name of the workspace we'd like to create. So here, I'll create a workspace named develop. And now if you look in the Explorer pane in VS Code, you'll see we have a new folder named terraform.tfstate.d. And if we open the folder, we see it includes a folder named develop. And if I create an additional workspace named test and open the Terraform tfstate.d folder again, now we see we have an additional workspace. And if we execute a Terraform workspace list command again, we see we now have 3 workspaces. And currently we're in the test workspace, as we can see here as well. And this is because when you create a new workspace, you're automatically put into that workspace. So if I want to switch from the current workspace that I'm in, which is test, back to the default workspace, I'll execute a Terraform workspace select, passing it the name of the workspace I'd like to use. And now we see we're back in the default workspace. And notice that inside of the terraform.tfstate.d folder, there is no default folder, only folders for the new workspaces that we created, because the default workspace is applied to the default project. Now, what I want to do is configure the EC2 instance type to be specific to the workspace I'm working in. So, in the case of the default workspace, I want to use a T2 Nano. In the case of the develop workspace, I want to use a T2 Micro. In the case of the test workspace, I want to use a T2 Small, and I'll create a new workspace named prod, which in this case, I want to use a T2 Large. Now, in the main.tf file, I'll create a variable named instance type, which is a type of map. I'll set the default properties equal to default having a value of T2 Nano, develop having a value of T2 Micro, test is a T2 Small, and prod is a T2 Large. Now, up in the AWS instance resource, instead of hard coding the instance type, I'll use a Terraform lookup function, passing it the variable instance type and the Terraform workspace. So when this code is executed, it will go to the instance type variable, which is a map, and then look for the current Terraform workspace, which in this case, I'm currently in default, and return the value of T2 Nano. Now in a terminal, I'll execute a Terraform workspace show just to ensure that I'm in the default workspace, then run a Terraform plan. And here we see we have one resource to add, which is our EC2 instance. Now, if we scroll up, and then find the EC2 instance type, we'll see that its value is a T2 Nano. That's because I'm in the default workspace and T2 Nano is the instance type that was returned from the lookup. Now, if I do a Terraform workspace select develop to switch to the develop workspace and run a Terraform plan, and then scroll up and find the instance type, now we see the value is set to a T2 micro. Now, let's switch back to the default workspace and do a Terraform apply, which will provision the infrastructure on AWS. And after the apply is complete, if we look into the Explorer pane, we see we have a terraform.tf state file in the root of our project. Now, this is the TF state file for the default workspace. If I switch back to the develop workspace and run a Terraform apply, if we look inside the develop folder in the terraform.tfstate.d folder, we see a terraform.tf state file for the develop workspace. If we look inside the terraform.tf state file for the default workspace and search for instance type, here we see the T2 Nano. And if we open up the terraform.tf state file in the develop workspace and search for instance type, here we see the T2 micro. So that concludes this video on Terraform State. In the next video, we'll take a look at securing secrets in Terraform. If you'd like to be notified when I add that video to the playlist, please consider subscribing to the channel. And if you found this video informative, feel free to give it a thumbs up. Thanks for watching, and I hope to see you in future videos in this Infrastructure as Code on AWS with Terraform playlist.